Hey guys, Mr. McKinney here, just going over position, velocity, and acceleration. So if we start with a position graph, you'll see it as S of t, or sometimes you'll see it as x of t. If we start with a position graph, the main idea here is that the derivative of position is velocity, and that the derivative of velocity is acceleration. So if we start with position, and then we take the first derivative, we're going to get velocity, and then if we take the second derivative, we're going to get acceleration. That is the most important thing to get out of today's lesson. So let's go through it a little bit more in detail. So if we start with S of t as our position, sometimes you'll see it as a height or a position, but if we're measuring the distance, we're talking about S of t, or sometimes you'll see it as x of t. If we take the derivative of that position function, that'll give us the velocity function. So the derivative of position is velocity. A positive velocity means we're moving away, or if you're moving forward. A negative velocity would mean we're moving towards something, like coming back at you or moving backwards. Zero velocity means you have a constant position or you're not moving. If we take the derivative again, so the second derivative of position is acceleration, or the first derivative of velocity is acceleration. Again, we're just taking the derivative each time. So when we talk about acceleration, a positive acceleration means that the velocity is increasing. Negative acceleration means the velocity is decreasing. Zero acceleration means the velocity is constant. Note that it could be at rest, but it isn't necessarily. So you could have an object at rest, then the velocity would be zero. But zero acceleration just means it's moving at a constant velocity. One major thing to keep in mind is that positive acceleration does not mean speeding up. So positive acceleration does not mean speeding up. In order to be speeding up, you need to have the same signs between your acceleration and velocity. And we're going to talk about that a little bit more in a few slides. Actually, I think it's in a different video. But that's an important thing to keep in mind. If you are speeding up, then velocity and acceleration have the same sign. And if you are slowing down, then they have different signs. It's not a matter of whether acceleration is positive or negative. It's a matter of whether acceleration is the same sign as velocity or not. All right, so let's look at a vertical motion example. So a dynamite blast propels a heavy rock straight up with an initial velocity of 160 feet per second. So this picture shows what happens. It goes up, and then it hits the top, and it comes back down. And for a moment at the top, the velocity is going to be zero, which is an important thing to keep in mind. You're not allowed to just use graphs to answer questions. You have to use calculus, and you have to use the equations, so an algebraic analysis. We have an equation to model the height. Height is just another way of saying position. So if we want to look at the acceleration or the velocity, velocity is the first derivative, acceleration is going to be the second derivative. And let's look at a variety of different questions that we could answer if we're given a position equation. So how high does the rock reach? Now, some of you guys may want to just graph this and say, hey, look, here's the high point. You will not get any credit on the AP exam if you do it that way. So we have to be able to answer it with an algebraic analysis. So in order to answer how high does the rock reach, we're going to think about the fact that we know that at its max point, the velocity is zero. So basically, how high does the rock reach when the velocity is equal to zero? So let's find an equation for the velocity. We said that the derivative of position is equal to my velocity equation. We can use the shortcuts because it doesn't say anything about definition of the derivative. So the derivative of 160t is 160. The derivative of negative 16t squared would be negative 32t. So this is my velocity equation. Now, in order to answer this question, I'm going to need to know when the velocity is equal to zero. So I'm going to set this equation equal to zero. I can go ahead and move the 32t over to the other side and then divide by 32. So 5 is going to be equal to t. This is measured in seconds on this problem. Now note that the question didn't ask when does the rock reach the highest point. I just had to find that to answer this question. So how high does the rock reach? I need to take that time and put it into the height equation or the position equation. So I'm going to try to figure out what S of 5 is equal to. So 160 times 5 minus 16 times 5 squared. So S of 5, 116 times 5, 160 times 5 would be 800 minus 16 times 5 squared. Whoops. Nope, we're fine. 16 times 5 squared, that'd be 16 times 25, which would be 400. And then S of 5 would be equal to 400 feet. So the max height would be 400 feet. And again, to answer this, you cannot just look at the graph. Yes, the maximum is going to be at the point 400 if you look at the graph, but you won't get any credit on the AP exam. So you'd have to find when the velocity was 0 and then take that time and plug it into the position equation. All right, let's stay with this same problem and look at other questions that could be asked. So what is the velocity of the rock when it is 256 feet above the ground on the way up and on the way down? So it's giving me 256 feet above. That is a position. So that's an S value. So let's find out when that position equation is equal to 256. So we're going to say S of t is equal to 256. So we're going to say 160t minus 16t squared is equal to 256. In order to solve a quadratic, we want to make it equal to 0. I'm going to move it over to make the quadratic term positive. 16t squared minus 160t plus 256. I can pull out 16. So 16 times t squared minus 10t plus 16. And then I can factor t minus 2, t minus 8. So the position is equal to 256 feet, when I solve this equation. So when t is equal to 2 and when t is equal to 8 seconds. So the question is, again, it didn't ask me when was it 256 feet. It asked what is the velocity when it's 256 feet. So now I have the times, and I'm going to plug them into the velocity equation. So let's do 2 seconds first. V of 2 would be 160 minus 32 times 2. So V of 2 would be 160 minus 64, which would be 96 feet per second. And then let's look at, that would be on the way up, and then on the way down, let's look at V of 8. So this was at 2 seconds. On the way back down, it's going to be at 8 seconds. So V of 8 would be 160 minus 32 times 8. So V of 8, let's do 32 times 8. 256, so 160 minus 256, which is going to give me negative 96 feet per second. And those of you guys that have taken physics know that this is always going to work out this way, where it's going to be symmetric. So the speed going up and the speed going down are the same. Notice that speed doesn't matter whether it's positive or negative. So these speeds are the same. The velocities are different because this velocity is positive and this velocity is negative. The question asked for velocity, so it would be important that I had a negative answer here and a positive answer here. But the speed at that height is the same going up or coming down. All right, let's keep going with the same main problem. What is the acceleration of the rock at time t equals 3 during its flight? Acceleration is just going to be the derivative of velocity, or the second derivative of position. So the acceleration, the constant would go away when I take the derivative, and the derivative of negative 32t would be negative 32. Notice that there's no t value here. So since the acceleration is just negative 32, the units in this problem would be feet per second squared. It doesn't matter what time I plug in. The acceleration is always 32 feet per second squared. And this is also known as gravity. But in this particular problem, the time does not matter. The acceleration is always the same. The second derivative of a quadratic is a constant. So negative 32 feet per second. All right, what is the velocity at 42 seconds? So we already have an equation for velocity. It was just the derivative of position. So I can just plug in 42 seconds. So v of 42 equals 160 minus 32 times 42. So off to the side, I'll do 32 times 42, which is a nice big number. So v of 42 equals 160 minus 32, minus 1344, which would be a very large negative number. So 1 minus 160, let's see, 8, 11, negative 1184 feet per second. And you did all the math right, but this is wrong. We need to stop and think for a second. At 42 seconds, the velocity is 0, because this rock is just sitting here on the ground. It only took 5 seconds to get up. It's going to take 5 seconds to get back down. Now let's do the math to prove that. So the rock starts and finishes when the height is 0. So let's figure out when that happens. So S of t, which is 160t minus 16t squared, is equal to 0. 16t times 10 minus t equals 0. If I solve this equation, my two solutions are t equals 0 and t equals 10 seconds. These are the times when it's on the ground. This problem only makes sense between 0 and 10 seconds. 42 seconds is outside the domain where these equations would make any sense. So what is the velocity at 42 seconds? 0. But make sure we use our brains a little bit. So in calculus, you got to stop and think about the problem before you immediately just start plugging things in. All right, last one, when does the rock hit the ground? We just did that. The rock hits the ground when the position is equal to 0. So let's look at how we did that again. We would just say that 160t minus 16t squared is equal to 0. I can factor out a 16t. So then my answers would either be t equals 0 or t equals 10 seconds. This was the original time, so the t equals 10 seconds is what we're looking for on this problem. All right, so this was the first of many videos on position, velocity, and acceleration. Hope it made sense.